Today I'm going to go over how to deep clean our pH probes and how to do a regular cleaning as well, first before a deep clean, and how to change out the cell buffer solution or the salt bridge solution that's underneath the salt bridge, as well as some of the finer points in doing all these things properly and not damaging the probe. So the first thing I want to show you is we have three different types of probes, and they require different types of treatment. There's the Sensor X probe that's like this. It's similar to the Aquametrics probe like this. However, the Aquametrics probe uses a 15 millimeter wrench to remove the salt bridge. The Sensor X uses a 9 millimeter socket to remove the salt bridge. And this 1-inch Aquametrics probe, you must use a 1/2 inch wrench. There's the salt bridge eye. You have to be extremely careful when you turn this. You can rotate it like this, very careful, and not to bump the wrench into the bulb. If you push on that bulb while opening it with the wrench, it'll make leverage and it'll crack the bulb in there. Okay? When you're tightening it, you just have to take your time. You're going to do it vertically so that the solution doesn't leak out. I'm just going this way. I wouldn't use the screwdriver. I really haven't had the greatest success with that. A large Phillips screwdriver may work, but if it's already loosened up, sometimes the wrench is needed. Now, it only needs to be finger tight when you retighten them. The gaskets do the sealing. It doesn't need a lot of pressure. So those are the three salt bridges again. The 15 millimeter again on this one. The other one uses a 9/16. I usually use sockets on these because you're less likely to bump into the crystal or the bulb when you're using a socket versus an actual open-end wrench on those. All right. Before we go to the salt bridge aspect of it, I want to show you how we recommend doing the cleaning. We really want to use I like to use a natural bristle brush, like you can get at the hardware store. It has pure bristle. The reason is this plastic bristles like toothbrushes and things like that, the plastic gets embedded with solids or little bits of dirt, and then it acts like an abrasive when you're brushing the probe. So the natural bristle brush can be reused several times, and then they can be thrown out. They're fairly inexpensive. Otherwise, you would use mine several times. All we need to do is get a soapy solution started. So a little bit of water, and I really like our filter clean that we use for the filter cloths. If I put a 1/2 inch of water in there, all I need is like a 1/4 inch of filter clean mixed in with that. And that'll be my soapy solution that I can clean these probes up with. So I'll take this one over here by the sink, and we'll look at that, how I clean this off. So once I have a soapy solution like this, you can see it's a very aggressive soap, the filter clean. So you don't need to use it straight. You can dilute it, maybe 3 to 1 or something. 1/3 soap, 2/3 water. Then use this bristle brush. Careful not to let the metal ferrule hit the crystal, but you can brush that off thoroughly throughout you can even clean if it's got a lot of ink the rest of this when it comes out of a system, and rinse it off thoroughly. But you can do that a couple of times and get that crystal and everything really clean with the filter clean soap. Once that's done, rinse off the filter clean soap thoroughly. If you can't get it by a sink, you can use a pour, in a bucket or something, and pour the water over it. That'll get the majority of the dirt off of this. Then, if we're doing a deep cleaning is more needed when you have a lot of scale built up on this bulb. We usually like to use muriatic acid in water, and so you want to put, This is actually a half and half diluted. If you have muriatic acid straight from the hardware store, you have to dilute it pretty much 1-to-1 with water, with tap water. If it's already been diluted like mine is, it's but half tap water, half muriatic acid. I tend to even put it back in my bottle and reuse it a few times if you're just using it for your pH probe. You have to get enough just to get the bottom of the probe underwater, under the solution of acid. Putting this in there, take your timer out and leave it for a good 5 minutes for that acid to work on the probe. It'll take off a lot of the lime scale that builds up on the bulb and make the reaction time much faster. It'll get it thoroughly cleaned off with the acid treatment. Usually only 5 to 7 minutes is necessary, depending. But you don't see the buildup of scale on the bulb with the human eye. Usually you can't really see it. Some places I do actually see the buildup when it's really, really bad. It's really cloudy looking on the bulb. But if every 3 to 6 months, depending on the wastewater that you're treating. Some places have to do it much more often because they use lime in the treatment, so it's going to be a little bit harder water. Other places you can get away with doing this every 6 months or so with the deep cleaning, meaning the acid in addition to the soap and water technique. But a good acid cleaning, I'm not going to do this for 5 minutes, but once that acid has had 5 to 7 minutes to work on that probe, you need to really rinse the acid off thoroughly. So I'll take it back to my sink and run some water on it. Okay. And it really needs to be dunked in water after an acid wash. So this is clean water here. I'm going to put it back in clean water and soak it for a good 5 minutes. If the probe is connected to the meter, you should be able to look at the pH on the meter and see what reading you're getting. It's gonna absorb some acid into this water, and this water will be get pretty acidic even after just absorbing some of that acid out of that plastic and off of that salt bridge and everything. So once you've soaked it, I even change it out the water once or twice after I soak it just for the first minute. Maybe I take that water, dump it out, and replace it with fresh water just to get all that acid out of the probe, off the probe, so that it starts reading closer to a 6 or something, 5.5 to 6.5 or something like that on water. You can even take pH paper and test the water, see if you're getting most of the acid out of the probe, because it won't come out right with just one simple rinse. And you definitely don't want to have this probe fail, calibration, because there's leftover acid in the salt bridge on the surfaces and stuff like that. So a good thorough rinsing after an acid clean is necessary. Once it's been thoroughly cleaned with acid, then you can go ahead and calibrate if you're not replacing the salt bridge solution or the salt bridge and the salt bridge solution. If you're replacing the salt bridge and the salt bridge solution, then we go one step further, and I'll go to that point next. So here's one probe I have ready to go. The salt bridge can actually be seen in the bottom of that capsule, or in that cavity down there. You can see a second bulb down below. So there's the primary one up here on top with its ground lug, and then the other electrode, basically the comparison electrode, is down in that cavity. I want to stress that really there's different solutions out there. Some companies actually, in a pinch, you can use pH buffer 7 inside here. It's not really recommended, though. The better solution is originally from the Great Lakes company. That was Great Lakes International from Milwaukee. They no longer exist. It was purchased by Hach, and it's Equi Transfer 7 pH buffer solution. there's another brand that works just fine. It's the SensorX stuff. We sell this. It's color coded blue. It's not that it's a pH buff. It's actual pH 7 is what it actually will read. But you need to rinse it out once. So fill it up and then pour it out so that it rinses it out before you put in fresh solution. Then fresh solution has to be put in to the bottom of the threads. So here it's probably a little bit high. You got to look at it and get it on the bottom 1 or 2 threads there, so you can pour out a little bit, get it to the point where it's just covering the bottom 1 thread or 2 threads in the bottom of this cavity. Otherwise it's going to over pressurize itself when you put the salt bridge in. Okay, there it is. Now it's down there at the bottom, basically at the bottom of the threads. You can't have a cavity though, so it has to actually be into the threads and not leaving a void just below the threads. It starts, that roof of that cavity starts to go to the side. So it has to be, it can't have air there. So it has to be into the actual threads themselves. Once it is, then you can begin to thread the salt bridge, either putting the old one back in if you're just changing out the solution itself. Sometimes that's all that's needed. Other times you need a new salt bridge itself. So with this one, this one with the Aquametrics brand, you need the 15 millimeter metric socket. Now it doesn't have to be cranked super tight, and there's 2 gaskets on these salt bridges. Make sure you don't double gasket. If there was one left inside the probe and you're putting a new one in, don't have it, there's one left over, have it, stack a second gasket on top of it. It should be one toward the top and one a little bit further in the bottom. Those gaskets will seal plenty. You don't have to over tighten this at all. They're plastic threads, otherwise they're going to break. And again, keeping away from the bulb, you don't want to hit that with anything, otherwise it'll break. So that's how you replace the cell reference solution, it's called. Refreshing the reference solution, acid washing it, and cleaning it first with the filter clean is really a really deep clean. Even if you still use the same old salt bridge, just giving it fresh solution, a good cleaning, a good acid wash, a lot of times they'll get these probes back to running smoothly again.